All right, 4 is called trig functions of any angle. So basically what we're doing is now moving the things we know about right triangles around our circle. That's the only difference. A lot of this is overlap with what we've been doing before, but what we focused on with the right triangle trig was that it was in the first quadrant, and now we're going to start to move it around. That's the only difference. So all of this first couple of slides we know already. Okay, we know what sine, cosine, tangent, cosecant, and secant and cotangent are in terms of your x and y coordinates. We know what our unit circle looks like. We know what our quadrant angles are. If we plot those angles, we could find the sine and cosine and tangent of all those angles. But what happens when we move it around our circle? That's the only difference. What happens when the radius is no longer 1? What happens when I move it from quadrant to quadrant? So it will look something like this. So example 1 says determine the exact values of the 6 trig functions of each angle theta. So if you look at A, okay, this is no longer a unit circle angle. They're giving you that the coordinate point at the end of that angle is 4 3's, which means that your horizontal distance is 4 and your vertical distance is 3. And then I have a right triangle from that, yes? A couple of days ago we went over triples. You remember the triple that is 3, 4, 5. The missing side is 5. This is where the triples are going to come in handy. If you don't know it, Pythagorean theorem, okay? But then I can just figure out this again. I know that theta is sort of off to the right, but theta is really in where that pink edge is. So the cosine of theta is going to be 4 over 5. The sine of theta is going to be 3 over 5. The tangent of theta is going to be 3 over 4. And then I do my reciprocal functions. Secant of theta, 5 over 4. Cosecant of theta, 5 over 3, and cotangent of theta, 4 over 3. So this is where, obviously, you have to know your right triangle stuff, right? I can't rely upon my unit circle angles anymore. I got to know my SOHCAHTOA and then how to apply it. If you look at B, your coordinate point is now negative 8, 15, which means you moved left 8 and up 15. So theta, although it's here, we transpose into here for my triangle to solve for that. So you'll always put theta, it's called a reference angle, we'll talk about it in a little bit. But you always put it where the x-axis meets the other side of the hypotenuse of your triangle, okay? The x value and the y value can be positive and negative. So notice that the 8 is negative this time, the y is positive. The radius, however, will always be positive. So it doesn't matter if the x and the y are positive, negative, positive, positive, negative. The radius will always be positive. Do you remember the triple that is 8, 15? It is 17, okay? If you don't know it, you work it out. You do 8 squared plus 15, negative 15, doesn't matter. 64, 225, and I get 289, and the square root of 289 is 17, and that's not an easy one to figure out because you can't break it down, right? There's no 17th prime. So you want to know that triple as well, 8, 15, 17. And then comes all the same things that we asked for before. So sine, cosine, tangent, cosecant, secant, cotangent. So sine 15 over 17, cosine negative 8 over 17, God bless you. Tangent 15 over negative 8, and then the reciprocal functions. 17 over 15, negative 17 over 8, and negative 8 over 15. So the signs, positive, negative signs are important on these. You want to pay attention to the signs on your coordinate. So x is always going to be the horizontal distance, y is always going to be the vertical distance. Easy stuff, right?
Do you guys like those, we don't simplify it?
Like convert it into a mixed number, you mean?
Yeah.
No. As long as it's simplified, as long as you can't simplify that fraction, you want to keep it improper.
Okay.
The only time we ever like really put mixed is when we're trying to graph them. That's it. Good so far? Yes?
Mm-hmm.
All right, so now you just have to draw the thing first yourself. The points on the terminal side of the angle in standard position determine the exact values of the 6 trig functions. So just one more step because it doesn't give it to you drawn out already. So if I have 4, 7, negative 4, 7, I'm going to go left 4. I'm going to go up 7. I'm going to draw my triangle and I'm going to put theta where the x-axis meets the terminal side. Is 4, 7 part of a triple? Nope. So I got to do 4 squared, and again, the negative doesn't matter because you're always going to square it. Plus 7 squared equals your radius squared, so c squared or r squared, which is 16 plus 49. 65 equals c squared. C equals, which is 5 and 13. That's not going to break down at all. So I keep it as square root 65. So sine 7 over root 65, which gets rationalized. Cosine negative 4 over root 65, which gets rationalized. Tangent 7 over negative 4. And then the reciprocal functions. Actually, let me do it down here. Remember, you want to flip it before you rationalize it. So square root 65 over 7. Otherwise, you're going to have to do extra work. Square root 65 over negative 4. And cotangent negative 4/7. Questions on that one? Okay, 3, negative 4, which means write 3, down 4. This is a triple. The hypotenuse is 5. The sine is negative 4/5. The cosine is 3/5. The tangent is negative 4/3. And then flip them negative 5/4. 5/3, negative 3/4.